Hi, and welcome to our channel Suppose Math. My name is Yasir Mahmood, and as promised, we are back with our first lecture in logic. So we will begin by stating the course outline. We intend to cover the following basic concepts in logic. So we will begin with the introduction and basic principles, what exactly logic is and how do we use it. And then we will move on to the mathematical formulation of logic. It is like setting the stage for logic. Like for example, in stage in grade 4 or 5, you study about natural numbers and the operations of addition, multiplication, and so on. And in this mathematical formulation, we will study what kind of operations are available in logic. And then we will move on to the propositional logic. And we intend to cover only these two logics, namely the propositional and predicate logic. Propositional logic, it deals with propositions, as the name suggests. And proposition is a statement which can either be true or false. So our mathematical model, it only contains two elements, namely the true and false. Whereas predicate logic is the more powerful logic. And even though propositional logic is very restricted and simple case of predicate logic, it still has many computational problems which are very hard to solve by even the computers. And we will discuss what does it mean to say some problem as being hard to solve. So that's more about computability theory, and we will cover in maybe our next course. The goal for today's lecture is that we will again look into the fact that logic is very important and where do we use logic. If you remember, we considered an example in our first lecture where we stated the importance of logic and how is it used. So today we are going to more formally discuss those topics and also what are the basic components of logic. So logic is about three things. First of all, you want to analyze and assess the truth value of certain statements. You want to find out if a statement is true or false. And by false, it means that you cannot a statement to be true because it contradicts your current knowledge in some sense. The second goal of logic is that you want to determine whether you can accept a statement based on your previous knowledge. So in a sense, you have your knowledge about A and you want to find out whether believing A forces you to believe B as well or not. And finally, you want to use logic in, of course, logical reasoning. As you are given a statement and you want to find out the reasons that why is this statement true. So these are the three basic components of logic. Of course, as I said earlier, logic is very broad field. There are many other components, many other extensions, but in this course, we are going to cover only these three. So why logic? I mentioned briefly in our first lecture that logic helps you in communicating with someone, and when you hear reasons, then you can make sure or evaluate those reasons as being rational or non-rational. And you also need reasoning rationally make your decisions. So that's how important logic is. And also, more and more interface between human and machine, it uses logic. You might have heard about logical gates, which are the basic components of the modern processors. And that's how human interacts with the computer. Also, if you have some experience of programming, your algorithm is just a collection of statements which are evaluated, and based on certain statements, your algorithm performs certain tasks. So logic is at the heart of the interaction between human and a computer. So when I say that it is very important to be logical when you communicate with someone, I mean the following. So there are some statements which we call paradoxes. These are the kind of statements which does not make any sense in the first sight, but if you analyze them logically, then there is a sense and there is precise meaning of everything. So this is how logic helps you in understanding certain statements. A paradox is such a statement which does not make any sense in the first sight, but there are tools available given by logic that helps to understand that statement better. One such example is liar's paradox. So consider this statement, I am a liar. So do you think this statement is true or false? Well, we can analyze this. If I'm a liar, then this statement should be true because it does not contradict with the fact that I'm a liar. But on the other hand, I have just spoken the truth and I told you that I'm a liar, which means that this statement should be false. So in a sense, this is a circular statement, and this statement is true if and only if I'm a liar. And if I'm a liar, then this statement cannot be true because I lied about this statement. So we will analyze this statement once we have set the stage for our logic program, and of course, when we have all the tools available. And we will also consider many other paradoxes, such as the famous Barber's paradox. But of course, in the first place, we need to set the stage and we need to equip ourselves with all the tools that we need in order to study these paradoxes. Let's see with the help of some examples whether you have seen logic in action before or not. We claim that you have seen logic and you have used logic in your life even before attending these lectures. Consider the following statements. Either I make juice or I make tea. Now, there are some highlighted words. We will discuss those words in our next few slides. But at the moment, I'm only giving you examples that this is indeed logic in action. And in fact, there are more statements. You want to evaluate the truth value of each statement. For example, the second statement is true when the food is really ready and the guests are already there. Then you can say that this statement is true. And if, for example, the food is not ready or the guests are not here, then irrespective of the other part of the statement, this statement is going to be false. The third example is that today is not Monday. Can you guess when is this statement going to be true? Well, this is true on all days except Monday. You have also heard examples of the verb type 4. So, if you are sitting in your room and you observe a person that enters the house and he is wet, then you conclude that this might be raining outside. And finally, if I go to work, then you have holiday, and you have holiday, then I go to work. This statement is true if whenever I go to work, you do not go to work. And for example, if we both go to work, then this statement is not true because according to the first half of the statement, if I go to work, then you have holiday. And similarly, if we are both at holiday, then this statement is also not true because according to the second part of the statement, if you have holiday, then I must go to work in order for this statement to be true. Let's get to our first definition in this course on logic. A proposition is a statement that can either be true or false, and you can systematically classify whether the statement is true or false. For example, all the 4 statements in the following example are propositions. It is raining. You can just look outside and said whether this statement is true or false. And similarly, all the other 3. But not every statement is a proposition, as you can see in the following examples. Stop that. This is not a proposition because you cannot say whether this is true or false. And also, I promise that he comes is not a proposition because this is not some statement that can be classified as true or false. According to the form of the statement, it depends upon a person really comes or not. And I'm promising in advance, which means after reading this statement, you cannot really tell whether this statement is true or false. Can you classify the following statements as if they are propositions or not? So June 19, 2020 is Sunday. I will upload a video tomorrow, and your task is to write in the comment section whether any of these 2 is a proposition or not. And if you are already intelligent enough, then you can maybe also give a reason that why is this a proposition or why is this not a proposition. Propositional logic is formed from propositions using the logical connectives, and we have 5 of them available in propositional logic. These are called and, or, not, if then, and if and only if. Now, intuitively, all these 5 connectives has meaning that you have heard since your childhood. But now we will give them precise meaning. They also have some nice names in logic. We call them, the AND operation is called conjunction, Or operation is called disjunction, and you can see the symbols for them in front of them. And not is called negation. It also comes from negative, negation. The fourth operator is if then. We also call this implies, or in logic we call this implication, and this is just a right arrow. And finally we have if and only if, which is also called by implication in logic, and it's the arrow with head on both sides. Here are some examples where you combine the propositions with the help of logical connectives. So all of these are propositional formulas. The light is on and the student is reading. And in order for this statement to be true, both sub-statements, the left-hand side and right-hand side of and should be true. And intuitively, this is how we define and. Whenever you put and between two statements, both of these parts should be true. And the second statement is an example of or. Today is Sunday, or today is June 17th. You can also check that these two sub-statements, that is the left-hand side and the right-hand side, they are legitimate propositions because you can assign the value true or false to each of them. Or, as you can imagine, means that at least one of these two statements should be true in order for the whole statement to be true. The third example is staying at home is fun, and then a negation in the beginning. This statement is true if and only if what is inside the bracket, the proposition, this is false. And if staying at home is not fun, then this statement is true because of negation. Finally, and perhaps the most interesting statement is the fourth one, an example of implication. So lockdown is over implies I go to the university. This statement is true if lockdown is really over, then I go to university. Or when the lockdown is not over, then I may or I may not go to the university. But whenever the lockdown is really over, then I have to go to the university in order for this statement to be true. Finally, the last statement is by implication. It says, I eat my food if and only if I am hungry. This means if I eat my food, then I am hungry. And if I am hungry, then I eat my food. So in a sense, the implication simply says that these two statements are equivalent. They have to be true or false at the same time. And for example, if I'm not hungry, but I eat my food, then this statement is false. So this was just a stage for our introduction. And in our next lecture, we will define these logical connectives more formally. We will call what is called a truth table for each of these connectives. And a truth table simply states when is the whole statement true, which is connected by, for example, AND operation. And we will also discuss the concept of an assignment, which simply says that we should give a truth value. And we will also consider the concept of an assignment, which is simply stating the truth value of a proposition based on our observation. For example, in the first case, we want to evaluate the truth value of first statement when, let's say, the light is on, but the student is not reading. So this is one assignment. Finally, we will consider the concept of truth values and the truth values of all the connectives that we have considered in this lecture today. I hope that was interesting and motivational enough. So thanks for watching and stay tuned for our next lecture.